All right, welcome back. We're going to talk about multiplying polynomials. Before we talk about multiplying with polynomials, let's just talk about multiplying. Something you guys are familiar with, something like 2 times 5. I could visually represent this as a width of 2 and a length of 5. And if I divide this up, right, okay, this is the same as having an area of 10, right? So we know that 2 times 5 is the same thing as 10. If I add up all these bits, I got 10 pieces, right? So we're going to take this example here, this visual grid, and we're going to apply it to something a little more complex, where we're multiplying with variables. So if we have something a little more complex, maybe it looks like x plus 7 times 3y minus 4. I can take the same idea of how this is like my length and my width, and I can kind of translate that here in what we call an open area model. So this is our length, which is x plus 7, and so my length would be x plus 7, and then this can be my width, which is 3y minus 4. Okay. And then I can kind of complete my grid, and then I can multiply each piece. So here, these are all a width of 1. And so when I multiply them, 1 times 1, each of these units were 1, and I added up a bunch of 1s to give me 10. So we're going to do a similar idea here, where we have 3y times x. That gives me 3yx. Negative 4 times x gives me negative 4x. Again, my outer length and width multiply to give me my inside. So 3y times 7 is 21y. And then 7 times negative 4 is negative 28. So I can rewrite this, just like this one, how I added up 1 plus 1 plus 1 plus 1 plus 1, blah, 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 to give me 10. I can also add up my inside pieces here to get my new expression. So 3yx plus negative 4x plus 21y plus negative 28. Okay, I could rewrite this as 3xy minus 4x plus 21y minus 28. And that would be our final expression.
All right, let's practice using this area model to multiply 6x minus 1 by 2x minus 4. So, like the previous example, we can take just the length and the width of one piece of this area model. So 6x times 2x. Well, we know that 6 times 2 is 12. And then x times x we can write as x squared. Okay, and then we'll come down to this one right here. We have 6x times negative 4. So we have 6 times negative 4 gives me negative 24. And then we have x. Okay, and then we can come up here. We have 2x times negative 1. And that's going to give me a negative 2x. And then a negative 1 times a negative 4 will give me this box right here. When I multiply a negative times a negative, I have to remember that it turns into a positive. So negative 4 times a negative 1 will be positive 4. So now that I have all of this multiplied together, I can rewrite it as a sum of the whole inside added together. So I can rewrite this as 12x squared minus 2x minus 24x plus 4. Okay, and then I can even simplify a little bit more by combining these like terms. I have a negative 2x and a negative 24x. So I can combine these two to be a negative 26x. Okay, and I still have my 12x squared minus 26x plus 4. This will be the simplified way that I can write 6x minus 1 multiplied by 2x minus 4.
All right, let's say we have these polynomials being multiplied, 3m plus 5 times 2m squared minus 4m minus 1. An open area model could be really helpful for us here, if this represents the length of our open area model. So 3m plus 5, 3m plus 5. Separate terms we want to separate. And we got our width here of 2m squared minus 4m minus 1. 2m squared minus 4m minus 1. Awesome. So now we can do what we've been doing before, where we multiply each individual length and width. So 2m squared times 3m. 2 times 3 is 6. M times m squared. There are 2 m's here and 1 m here being multiplied. So altogether I have 3 m's being multiplied. 6m cubed. Negative 4m and 3m. Multiply those. We get negative 12m squared. Don't forget the squared. Well, our students forget that. M times m squared. Negative 1 times 3m is negative 3m. 2m squared times 5 is 10m squared. 5 times negative 4m, negative 20m. And 5 times negative 1 is negative 5. Sometimes the plus and the minus can be confusing because you might think, oh, 5 minus 1 is 4. But remember, we are always multiplying to find the area of a rectangle. All right, now we can just combine all our pieces together. You can do it in one big string. 6m cubed minus 12m squared minus 3m plus 10m squared minus 20m minus 5. You'll see on derivatives sometimes it asks you to simplify your expression or to collect like terms is the phrase they use. So I can combine my m squareds here. I'm going to leave 6m cubed because it cannot combine with anything else. 6m cubed. Okay. We got negative 12m squared here and 10m squared. They are like terms. Negative 12 plus 10 is negative 2m squared. We got negative 3m here can combine with negative 20m. So negative 3 plus negative 20 is negative 23m. And then I just have this negative 5. So if I were to multiply 3m plus 5 times 2m squared minus 4m minus 1 is the same as 6m cubed minus 2m squared minus 23m minus 5.
All right, now we are going to practice using the distributive property to multiply these two polynomials together. So if you want to draw an area model every time, that totally works and it's a great visual. But if you don't want to draw it every time, we can do the distributive property like we did in the last video, but we can just do it twice. This whole piece is being multiplied. 3 plus 4y is being multiplied by x minus 2. So we can take this 3, and we'll start with just this 3. We can say that 3 is being multiplied by x, and 3 is being multiplied by negative 2. But not only is 3 being multiplied by both these terms, but this 4y is also being multiplied by the x and the minus 2. So that's when we do the distributive property for the second time, and we'll do 4y times x and 4y times negative 2. So we'll start with this 3, okay? 3 times x gives me 3x. 3 times negative 2 gives me negative 6. Then I can come to my 4, and I can say 4y times x gives me 4xy, and it's a positive. So we'll have positive 4xy. And then I have my 4y times a negative 2, so that will be minus 8y. So then I can look through and see if there's any terms I can combine, but it doesn't look like I can because I have an x, a constant, and then an xy, and then a y. So I can just leave my answer. Just remember that each term has to be multiplied by each term in the second part. So the 3 is multiplied by the x and the minus 2, and then the 4y is multiplied by the x and the minus 2 as well. So if you were to do an area model, we can see that the pieces inside of our area model are going to match up with the pieces that we found here. So if we add them all together, we'll have 3x plus 4xy minus 6 minus 8y. And we can see over here, we have 3x, and it's okay if they're in a different order. We have our 3x, and then our minus 6's match up, our plus 4xy, and our minus 8y matches up. So either way works, whatever one you prefer. Just make sure that when you're doing the distributive property that we're doing it twice, right? We're doing it with this term, and then also with our second term.